In this section, we'll be solving linear systems by substitution. Now, if you viewed the previous video where we did an application of solving linear equations, of solving a system, we actually touched on solving a linear system by substitution. We just didn't know at the time. So if you recall, we had something that looked like this. We had b equals 100t, and we had a second equation. This is actually at the last part of our application. We had b equals 75t plus 200. All right, and we wanted to know when these two equations here intersected on a graph. Well, if you recall something that we already know, not to insult your intelligence, but a equals c, and if b equals c, then we can deduce that a equals b. Okay, we know this. So if b equals 100t, and this equation also equals b, we can plug in 100t for b here, or in essence, we can set these two equations equal to each other and solve for t. That's actually what we did. We set 100t equal to 75t plus 200, and we solved for t, which turned out to be 8. All right, now what we did is we plugged t, since we have the value for one variable, we plugged it back into, actually we can plug it into either equation, but we plugged it into one, and we saw that b equals, if we plugged into this one, 100 times t, which is 8, equals 800. What this means is that our values t equals 8 and b equals 800 tells us that our two lines intersect at the solution point 8 and 800. And that's actually what we found because we answered a question regarding that. So this is actually what we've been wanting to know. We've been solving systems of equations by graphing, but notice, if you remember, we only got an approximation of where the intersection was. Well, now we're going to learn a few strategies about how to find the exact solution for the system of equations. And the first one is the one we just used, and it's called solving the linear systems by substitution. So we'll do several examples of these. So let's go ahead and jump in. Our first system is we have 2x minus 5y equals minus 6, and 3x plus y equals 2. All right, so here's our system of linear equations. If you will, we have equation 1 and equation 2. And looking at these two standard form equations, we need to solve one of them for one variable in terms of the other variable. And then we can simply substitute into the other equation. So let's go ahead and solve the second equation, equation 2, for y, since it doesn't have a coefficient. And it's actually just a quick one-step solve. So let's take equation 2, which is 3x plus y equals 2, and solve it for y. So let's go ahead and subtract both sides by 3x. Those two terms cancel, so we have y equals minus 3x plus 2. So we have one equation, we have one variable solved. So what we can do is we can plug this into the second equation and solve for x. All right, so let's go ahead and do that. We know what y equals, so we can plug it into the other equation. So let's go ahead and do that. Let's pick another color. So we have the first equation of 2x minus 5y, but we know what y is, so we're just going to substitute that expression in for our variable. So we have minus 3x plus 2 equals minus 6. Now we can go ahead and solve this for x. We have 2x. We can go ahead and distribute this 5 into the parentheses. So minus 5 times minus 3x is a positive 15x. Minus 5 times 2 is minus 10. And we still have our minus 6 on the other side. And we can go ahead and solve for x by combining these two like terms, 17x. We can add 10 to both sides in the same step, which will cancel those two terms. So we just have 4 on the right-hand side. And we can isolate our variable by dividing both sides by 17. So we have x equals 4 over 17. So we've solved one equation for one variable in terms of the other variable. Now we use that to substitute it into the other equation to get an actual value for one of our variables. Now this is important because now that we have a value for one of our variables, we can plug this into either equation to get the value for the other variable. All right, now so since Equation 2 is just slightly simpler than equation 1. Let's go ahead and plug this 4 over 17 in for x and solve. So we have 3 times x, which is 4 over 17, plus y equals 2. And all we do is simply solve for y. So we have 3 times 4 is 12 over 17 plus y equals 2. We can go ahead and subtract 12 over 17 from both sides. Minus 12 over 17. Those two terms will cancel. We're just moving down here. Y equals, so let's convert 2 into a rational number with a denominator of 17. So we have 34 over 17 minus 12 over 17. And that'll give us 22 over 17. So that's y. So now we actually have our values for our two coordinates. So we can write the actual solution for this system of equations as 4 over 17. That's 4 over 17, sorry about that. 4 over 17 and positive 22 over 17. This is the intersection of these two lines, and it's indeed the solution for the two equations. All right, so we're solving linear systems by substitution. Let's go ahead and do some more. These are actually fairly simple once we get a good handle on them. So we have the system minus x minus 4y equals 8. And we also have x over 2 plus 3y equals 1. All right, now what we want to do is we want to solve one of these equations in terms of one variable in terms of the other variable. This first equation is going to be a little simpler to deal with, so let's go ahead and solve it for x. So we have, let's pick another color, we have minus x minus 4y equals 8. Let's go ahead and isolate x since it's pretty much by itself. We'll deal with that in a second. So let's add 4y to both sides. These two terms will cancel, so we have minus x equals 4y plus 8. We want to solve for a positive x, so let's go ahead and divide everything through by minus 1, which essentially just flips all the signs. So we have x equals minus 4y minus 8. All right, so we have one of our variables solved in terms of the other variable. So now let's go ahead and plug this into the other equation so we can get a value for y. So we know x, so let's go ahead and plug that into our second equation. So we have minus 4y minus 8. Minus 4y minus 8 is plugged in for x up here in our second equation, divided by 2, plus 3y equals 1. All right, now a little simplification will do a long ways, so let's go ahead and factor out a 2 from all three of these terms, and that'll get rid of the denominator in the fraction bar, which will help us out a lot. We're left with minus 2y minus 4 plus 3y equals 1. All right, so we'll just go about simply solving for y by combining like terms. We can add 4 to both sides, so we can cancel these two terms, and we can combine the coefficients of y. So we have 3 minus 2, which will give us 1, so just y equals 1 plus 4 is 5. So we have an actual value for one of our variables. Variables of y equals 5. So all we need to do is plug that into one of our equations to solve for the other variable. This one has a fraction in it, so I'd rather deal with this one. So let's plug in 5 for y in this equation. So we have minus x minus 4 times y, which is 5, equals 8. And it's just simple mathematics here. Minus 4 times 5 is a minus 20, equals 8. We can add 20 to both sides. These two terms will cancel, so we have minus x equals 28. And if you want to divide both sides by 1, we can get x by itself, a positive x. So we have x equals minus 28. If you don't want to divide both sides by 1, we can just flip the sign of both sides because there's just two terms. So This minus x becomes a positive x. Positive 28 becomes a minus 28. So now we have the value of both y and x, so we can write our exact solution to this system of equations, which is minus 28 and 5. This is the point where these two lines intersect. So this point satisfies both of these equations, and you can actually check this by plugging in these two values for the respective x and y's in both equations, and you'll see that it works in both equations. So we'll be dealing with solving linear systems by substitution. Much more. We'll do at least a few more videos just on this technique before we move on to another one. So I'll see you in the next video.